Tonight we are going to grant humanity its ultimate impossible wish. We are going to imagine that every physical barrier has finally shattered. Every engineering limit, every struggle with fuel, and every law of mass has simply evaporated into the dark. We have built the ultimate machine, a ship that can move at the speed of light, 186,000 miles every single second. This is the absolute ceiling of the universe, the refresh rate of reality itself. Moving at this speed should feel like victory. It should feel like we have finally conquered the silence of the stars. But here is the realization that is going to change the way you look at the night sky forever. Even at the speed of light, you are still standing still. In the grand scale of the cosmos, the fastest thing in existence is an agonizing crawl. By the end of tonight, you're going to understand why the universe is a beautifully designed cage, and why even the fastest motion allowed by nature is too slow to ever let you truly come home. Before we set out, you first have to feel the thrill of the power we've just granted you. 300,000 kilometers per second. In the time it takes your heart to beat once, a beam of light can circle the entire Earth 7.5 times. You are moving at 670 million miles every hour. These are numbers that our biological minds were never designed to hold. A high-powered rifle bullet travels at 2,000 miles per hour. The Parker Solar Probe, the fastest piece of technology ever touched by human hands, only reaches 400,000. And you are now traveling 1,500 times faster than that. You have become a god of motion. For a brief moment, it feels like the universe is finally yours to claim. But to feel the weight of the disappointment that is coming, you first have to understand how we even discovered this number. For most of our history, we assumed light was divine, instantaneous, and infinite. But in 1676, a Danish astronomer named Ole Rømer noticed something unsettling while studying the moons of Jupiter. He saw that the moon Io appeared to slip into shadow earlier or later, depending on Earth's distance from the giant planet. That single insight changed the human story. It proved that light has a speed. It is fast, but it is finite. And if light is finite, it means that looking out into the stars is exactly the same as looking back into a graveyard. The stars you see tonight are ghosts of suns that may have died centuries before your ancestors were born. Light is a messenger that always arrives with news that is already old. Now picture yourself on the bridge of your ship. You look back at the blue spark of Earth, fire the engines, and instantly you are at sea. The moon is your first target. It sits 384,000 kilometers away. You blink and the moon is already behind you. It took you 1.3 seconds. Already the solar system feels like a small room. Next comes the sun, the furnace of our world. You cross the 93 million mile gulf in 8 minutes and 20 seconds. But think about what that means. The sunlight warming your skin on a summer afternoon is actually an 8-minute-old memory. Even at the ultimate speed, you are a passenger in the past. Let's keep going. You reach Mars in 22 minutes. You fly past the swirling storms of Jupiter in 43 minutes. You see the golden rings of Saturn in 1 hour and 20 minutes. By the time the afternoon is over, you have reached Neptune, nearly 3 billion miles from home. You have tamed the kingdom of the sun in a single day. But even on this glorious flight, something would haunt you: the emptiness. You realize that space is the most honest word in our language. It is mostly just empty. You've crossed the asteroid belt, and despite how it's pictured in our films, you saw nothing. The rocks are so spread out that you could fly through them for 1,000 lifetimes and never see a single stone. You are a god of speed, but you are a god in an ocean of absolute nothingness. This is the peak of the illusion. You've conquered the planets in a day. You think the stars are next, but hold on to that feeling, because as you pass the orbit of Neptune, the scale of the universe is about to perform a brutal surgery on your ego. Beyond the planets lies the Oort cloud, a vast spherical shell of trillions of icy bodies that mark the true boundary of our sun's gravitational empire. This cloud is not a thin ring. It is a gargantuan cocoon that stretches out for more than a year of light travel. The little ship that crossed from the Sun to Neptune in an afternoon would now need more than a year of continuous flight just to leave the Sun's frozen outer suburbs behind. And that is still home. That is still our own front yard. We haven't even started the real journey yet. This is the moment human intuition collapses. A light year is nearly 6 trillion miles. We switch to this unit because miles have become a useless language. Telling you a star is 25 trillion miles away is just a smear of zeros. But telling you it is 4 light years away is a warning. To understand why the stars are so impossibly far, look at the grain of sand model. If you shrank our sun to the size of a single grain of sand and placed it on a table, the nearest star would be 4 miles away. 2 grains of sand, 4 miles apart, with absolutely nothing in between. That is the texture of our galaxy. And your ship, moving at the fastest speed permitted by the laws of logic, must cross every single inch of that silence, 1 second at a time. By the end of this journey, you are going to understand why the dream of interstellar exploration is a biological mismatch. We are going to look at the galactic abyss and the redshift prison. We will see why the expansion of space is currently winning a race against the very light we are trying to use, and why 97% of the galaxies we see tonight are already physically unreachable, even at light speed. In the next section, we are going to look at the Moon-Mars sprint. We will discover why light feels like a miracle in our local neighborhood, only to betray us the moment we try to leave the light of our own sun. Are you ready to see why the speed of light is the most beautifully designed cage in existence? Imagine the thrill of your first hour as a god of motion. You are standing on the bridge of a vessel that has achieved the ultimate dream of the human species. The engines are silent, yet you're currently slicing through the fabric of reality at 300,000 kilometers per second. On Earth, we measure our lives in commutes, in hours spent in traffic, and in long, grueling flights across oceans. We are used to the idea that the world is big and that moving across it takes effort. But inside this ship, the old rules of the planet have been deleted. In this section, we are going to experience the Moon-Mars sprint, the miraculous afternoon where light speed makes the solar system feel like a small, sun-drenched room. We are going to discover why this initial mastery is the most dangerous deception of all, and how the very speed that makes you feel like a conqueror is secretly preparing you for a loneliness that has no name. Start with the departure. You look out the rear viewport at the blue marble of Earth, and before you can even take a full breath, the world you've known for your entire life has shrunk into a marble. You engage the light speed drive, and in exactly 1.28 seconds you have reached the moon. Think about the gravity of that moment. In 1969, the Apollo astronauts sat inside a tiny capsule for 3 days, vibrating with the roar of chemical rockets, risking everything just to touch the lunar surface. To them, the moon was the ultimate frontier, a distant white desert that required the full industrial might of a superpower to reach. To you, it is a blink. It is a hesitation. You pass the footprints of Neil Armstrong in less time than it takes to clear your throat. This is the first wait. What moment of the sprint? Light speed doesn't just shorten the distance, it insults it. It makes our greatest historical achievements look like the first uncertain steps of a toddler. But as you leave the moon behind, you realize that the thrill is not just about the destination. It is about the fluidity of the cosmos. On Earth, we are anchored by gravity and friction. In this ship, you are a ripple in the fabric of the universe. You point your bow toward the center of the system, and in 8 minutes and 20 seconds you arrive at the sun. But as we discussed, you aren't arriving at the sun of now. You are arriving at the sun of 8 minutes ago. You are traveling through a hall of mirrors, where every object you see is a ghost. You see a solar flare erupting from the surface, but that flare happened while you were still on the moon. You are realizing that at light speed, you are not just a traveler of space, you are a consumer of history. The next hour of your journey is a masterclass in cosmic insignificance. You fly past Mercury, a scorched, iron-rich pebble baked by the fire of the star. You reach it in under 5 minutes from the sun. You pivot toward Venus, the brilliant, toxic sister of Earth, and you are there in less than 7 minutes. By 22 minutes into your journey, you have reached Mars. On Earth, we talk about the Mars mission as the greatest challenge of the 21st century, a 9-month voyage of radiation and isolation. For you, it is a short wait between 2 songs on your playlist. You see the red dust of Valles Marineris and the peaks of Olympus Mons as rare, precious islands of color in an ocean of black. As you cross the orbit of Mars and enter the asteroid belt, the speed mirage begins to shift. We've been conditioned by cinema to see the belt as a crowded minefield, a place where a ship must dodge and weave between tumbling rocks. But as you scream through the belt at 186,000 miles per second, you see nothing. This is the acoustic silence of the void. The asteroids are out there, millions of them, but they are separated by hundreds of thousands of miles of absolute emptiness. You could fly at light speed through the belt for 1,000 years and never glimpse a single rock. You realize that space is the most honest word ever invented. It is not a place of things, it is a place of gaps, and you are currently the fastest thing in those gaps. 43 minutes into your flight, you reach the king of the system, Jupiter. It is a sprawling, colorful monster of hydrogen and ammonia, so large that it could swallow 1,300 Earths. You fly past the Great Red Spot, a storm that has been raging since before the telescope was invented, and you see the 4 Galilean moons as tiny, glowing sparks. In the time it takes to have a casual lunch, you have crossed a distance that took the Voyager probe's years to navigate. By an hour and 20 minutes, you are at Saturn. You see the rings, trillions of pieces of water ice reflecting the distant sun like a halo of diamonds. From Earth, Saturn looks like a fragile, beautiful jewel. From your bridge, it looks like a colossal industrial project of nature. But even here, as you marvel at the rings, the loneliness of sea begins to set in. You look back at the sun. It is no longer a disk, it is a very bright star. The warmth you feel through the hull is artificial, generated by the ship's reactors. The sun's influence is thinning. You have crossed the inner circle of your life, and you are entering the realm of the giants. 2.5 hours into the sprint, you pass Uranus, the tilted, cyan ice giant. 4 hours and 10 minutes in, you reach Neptune, the last true planet of the solar system. You have crossed the entire known kingdom of the sun in a single afternoon. If you were a king on Earth, this would be the moment of your triumph. You have conquered the distance that has defined our species for 4 billion years. You have moved faster than any biological impulse has ever dared. You feel like a god. You feel like the universe has finally been tamed. But this is where the pattern interrupt happens. The moment the universe performs a brutal surgery on your pride. You pass Neptune, expecting to see the stars grow larger. You expect the leap to begin, but instead you enter the Kuiper belt. You enter the Oort cloud, and you realize that your miraculous afternoon was just a walk across the welcome mat. The planets, the Moon, Mars, Jupiter, Saturn, were all huddled together for warmth around the Sun. They were the interior of the house. Now you have stepped out the front door and you are standing in the driveway. To leave the driveway, to cross the Oort cloud and truly enter the interstellar medium, your ship will need more than an afternoon. It will need a year. Think about the psychological collapse of that realization. You tamed the entire planetary system in 4 hours, but to reach the property line of your own house, you have to spend the next 12 months in a metal tube, watching a sun that never moves and a darkness that never changes. You have reached the absolute limit of the local miracle. The speed of light made the solar system feel small, but it is about to make the galaxy feel infinite. You are about to discover that you aren't a god of motion. You are an ant trying to cross a continent. In the next section, we are going to look at the Oort cloud wall. We will explore why the first year of your journey is a psychological prison, and why looking back at the sun from 1 light year away is the most heartbreaking sight a human can ever witness. We will see why C is not a bridge to the stars. It is the speed of an eternal exile. Are you ready to see why the driveway of your home is larger than your entire history? The transition from the world of the planets to the true interstellar void is a moment of profound psychological trauma for the light-speed traveler. Just a few hours ago, you were a god of motion. You crossed the moon's distance in a single heartbeat. You saw the Valles Marineris of Mars and the golden rings of Saturn flicker by like frames in a movie. In your first 4 hours of flight, the solar system seemed to shrink, becoming a small, sun-drenched room that you had finally mastered. You reached Neptune, the outermost sentinel of the planetary family, and you expected the leap to begin. You expected the stars to grow larger and the distance to yield. But as you pass the last of the giants and look out into the darkness ahead, the clock of the universe performs a brutal, cold reset. You are about to discover that the miraculous afternoon of Section 2 was just a stroll across the welcome mat of your own home. This is the third rung of the ladder, the Oort cloud wall. We are going to explore why reaching 1 light year from Earth is the most heartbreaking milestone in human history, and why the first year of your journey is a lesson in the absolute, crushing stiffness of space. To understand the horror of the Oort cloud, you must first forget everything your textbooks told you about where the solar system ends. We are taught that the boundary is Neptune, or perhaps the Kuiper Belt, the ring of frozen rocks where Pluto drifts in the dark. We draw our maps as if the sun's influence stops at the edge of the planets. But this is the perspective of a species that has only ever lived in a cradle. The sun's true empire is much larger and much lonelier. Wrapped around our entire world is the Oort cloud, a vast, spherical shell of trillions of icy bodies, remnants of the solar system's birth that were cast out into the cold by the gravity of the giant planets. This cloud is a cocoon of ice and rock that stretches out for nearly 2 light years in every direction. This is the true property line of your house. And it is here that your godlike speed hits its first invisible wall. To cross this driveway, to simply reach the fence of your own home, your ship, moving at the absolute maximum speed the laws of physics permit, will need to travel for an entire year. Imagine the psychological collapse of that realization. You tamed the entire planetary system in a single afternoon. You saw the fire of Mercury and the storms of Jupiter in less time than it takes to watch a movie. But now, to reach the front door of the interstellar medium, you have to spend the next 365 days in a metal tube. The rhythm of your journey has changed from the instant to the agonizing. On Earth, we think of a year as a long time, a cycle of seasons, a progression of history. But inside your ship at light speed, there are no seasons. There is no weather. There is only the low-frequency hum of the air scrubbers and the unchanging, frozen patterns of the stars in your viewport. You look back at the sun, and you realize that even at your impossible speed, the light of home is refusing to fade. You have spent months of your life screaming through the dark, yet the sun still looks like a brilliant, accusing needle of light. You are running as fast as reality allows, yet you are still standing on your own porch. This leads us to the first wait. What? Moment of the Oort cloud wall, the scale of the nothing. In section 1, we mentioned the grain of sand model, but to truly feel the stiffness of this year, we have to look at the density of the cloud itself. We imagine a cloud as a thick fog, a place crowded with ice and debris, but the Oort cloud is the emptiest place in the sun's domain. There are trillions of objects out here, but they are spread across a volume of space so vast that a comet in this cloud might have 10 million miles of absolute emptiness in every direction before its nearest neighbor. You are traveling through a graveyard where the tombstones are light years apart. For the entire duration of your first year at light speed, you will see nothing. No rocks, no ice, no worlds, just the void. You are moving at 300,000 kilometers per second, yet your environment is so stagnant that you would swear you were standing perfectly still. You are experiencing directional vertigo, the terrifying feeling that you are a mind trapped in a vacuum, with no landmarks to tell you if you are moving at all. Think about the causal lockdown that intensifies during this first year. On Earth, we are tethered by the speed of light, but at the edge of the Oort cloud, that tether becomes a leash. If you want to say goodbye to Earth as you leave the driveway, your message takes an entire year to reach them. Their reply takes another year to return. By the time you hear their voices again, 2 years have passed in their timeline. You are in a different now than everyone you have ever loved. You aren't just far away in space, you are becoming later than the human race. You realize that the speed of light, is not a tool for connection. It is a mechanism for isolation. It ensures that the further you go, the more the world you left behind turns into a historical recording. You are becoming a cosmic orphan before you have even reached the first neighbor. As the months pass in the silence of the Oort cloud, the distance trap reveals its final, most humbling truth. You realize that your mission was built on a biological mismatch. We are creatures of the local. Our brains evolved to hunt in forests and navigate valleys, places where speed and distance are in proportion to our lives. But the Oort cloud wall proves that the universe is built on a scale that ignores biology. To the cosmos, a year of light travel is a microscopic detail. To you, it is the best years of your life. You realize that you have spent a year of your existence just to leave the front yard, and you look ahead at the next wall, the 3.5 years of silence that separate you from Proxima Centauri. You begin to feel the stiffness of the void, the realization that even if you could move infinitely fast, the universe would still find a way to keep you apart. This is the point where the thrill of Section 2 turns into the dread of Section 3. You have reached the edge of the sun's gravitational empire. You are 1 light year from Earth. You look back and the sun is now just a point of light, the brightest star in the sky, but no longer a disk. It provides no warmth. It provides no sense of up or down. You have officially left the house. But as you step into the true void, you realize that you aren't a conqueror entering a new land. You are a castaway in an ocean that has no shore. You have used the fastest speed in existence just to realize how slow you really are. But as the Oort cloud fades behind you and the true interstellar dark takes hold, a new and much more physical threat is gathering at your hull. We think that if we can just survive the time, if we can just endure the year of silence, we will be safe. But the space between the stars is not as empty as it looks. While we worry about the clock, the vacuum itself is preparing a thermal and kinetic execution. In the next section, we are going to look at the Voyager benchmark. We will compare your impossible ship to the fastest machines humanity has actually built, and discover why at light speed, the very atoms of the void become high-explosive weapons. We will see why the property line of our home was the easy part, and why the between is a place where even light itself begins to break. Are you ready to see why the speed of light is not just slow, it is lethal? To understand the true cruelty of the light speed limit, we have to step out of our impossible ship for a moment and look at the cold, hard metal of human reality. We have spent this journey imagining a vessel that can move at 300,000 kilometers per second, a machine that defies the energy budgets of our entire planet. But while we dream of light-speed marathons, there is a real machine out there, built by human hands, that is currently teaching us the most humbling lesson in the history of our species. This is the story of Voyager 1, our farthest, fastest ghost, and the clinical benchmark it sets for every dream of the stars. In this section, we are going to compare your godlike speed to the absolute peak of what humanity has actually achieved with fire and gravity. We are going to discover why our fastest probes are effectively standing still in the intergalactic ocean, and why even the light speed miracle is just a faster way to realize how profoundly we are trapped. Start with the facts of our current reach. Voyager 1 was launched from the Kennedy Space Center on September 5, 1977. Its original mission was not the stars. It was a local survey of the giants in our own backyard, Jupiter and Saturn. To get the speed it needed, it didn't just rely on its engines. It used the massive gravity of the planets themselves, performative a series of slingshots that flung it into the dark with a velocity no rocket alone could provide. Since its final flyby of Saturn in November of 1980, Voyager 1 has been traveling on the same trajectory at a steady, unrelenting pace. It moves at approximately 17 kilometers per second, roughly 38,000 miles per hour. To our human biological intuition, 38,000 miles per hour sounds like a terrifying velocity. It is more than 20 times faster than a rifle bullet. It is fast enough to circle our entire planet in under 40 minutes. It is the fastest object human beings have ever launched into the deep dark, and it has been flying for nearly 50 years without a single second of rest. But here is the first what moment of the benchmark, the staggering, almost insulting gap between our fastest technology and the speed of light. Voyager 1 has been flying for half a century to cover a distance that light, the speed you are currently traveling at, covers in exactly 1 day. Think about that scale for a moment. In November of 2026, Voyager 1 is expected to reach a milestone that astronomers call 1 light day from Earth. This means that if you were to point a high-powered radio telescope at Voyager 1 today, the signal would take 24 hours to arrive. It has taken humanity's fastest machine 50 years of continuous flight to reach a distance that light crosses in the time it takes the Earth to rotate once. We are like an ant that has spent its entire life walking, only to realize that it has traveled the length of a single human footstep. If the distance to the nearest star were a marathon, our fastest probe hasn't even finished the first inch. This leads us to the 75,000-year sentence. If Voyager 1 were aimed directly at Proxima Centauri, which it is not, the journey would take roughly 75,000 years. Human intuition cannot process this span of time. 75,000 years ago, modern humans were sharing the planet with Neanderthals. Our entire recorded history, from the first grain of wheat planted in the soil to the invention of the atomic bomb and the internet, fits comfortably inside the last 10,000 years. Voyager 1 would need more than 7 times the entire history of human civilization just to reach the front door of one star, the nearest one. Every other sun in the sky is farther. Every other galaxy is millions of times more distant. This is the reality of our best effort, a journey that outlasts the very species that launched it. We built our fastest machine, we gave it the energy of planets, and it managed to cross the welcome mat of our house before its heart began to fail. And Voyager's heart is indeed failing. To stay alive in the cold of interstellar space, the probe relies on radioisotope thermoelectric generators, 3 plutonium hearts that convert the heat of decaying radioactive material into electricity. At launch, these generators produced roughly 470 watts of power, but the laws of nuclear physics are as indifferent as the distance. Every year, as the plutonium decays, the power budget of Voyager 1 drops by about 4 watts. By 2026, the probe is running on a trickle of energy, less than half of what it started with. NASA engineers have been forced into a clinical game of interstellar triage, turning off scientific instruments one by one, like putting a patient into a coma just to keep the brain alive. Within a few more years, the signal will vanish entirely. Voyager will become the quietest thing ever made, a dead piece of metal drifting through a silence it was never meant to break. Now look back at your impossible ship. You are moving at sea, you have closed the gap. You have turned 75,000 years into just over 4. This should feel like a victory, but as you pass the dead shell of Voyager 1 and look out into the absolute silence of the interstellar medium, you realize the second "wait, what?" moment. The speed of light is not a bridge, it is a chronological isolation. Even at the maximum speed the universe allows, your nearest neighbor is still a 4-year-long silent exile. You have used the most powerful magic in the laws of physics just to reach a distance that still outlasts most human marriages. You have traded 75,000 years of history for 4 years of solitary confinement, and you haven't even reached the first star system. The Voyager benchmark proves that distance in space is not a problem of fuel or engineering. It is a property of the universe that is fundamentally incompatible with the human lifespan. We are a species that lives for 70 or 80 years, trying to navigate a galaxy that is measured in thousands and millions of years of light travel. Even at light speed, the refresh rate of our species is too slow. If you were to launch a fleet of light-speed ships today to explore the nearest 100 stars, the people who launched them would be long dead before the first status report ever arrived. We are trying to build an interstellar civilization using a biological clock that was designed for a single planet. We are like mayflies trying to study the seasons of a world that lives for 1 billion years. Think about the archaeology of the record. Right now, Voyager 1 is carrying a golden record, a copper disc containing the sounds of Earth, the music of Bach, and the greetings of 55 human languages. We sent it as an invitation to the neighbors, believing that one day another mind would reach out and touch it. But as you drift past the Oort cloud at light speed, you realize the heartbreaking truth. No one is coming to find the record. Not because they aren't there, but because the silence is too wide. Voyager 1 will drift past a star called Gliese 445 in about 40,000 years. By then, the civilization that made the record will be as ancient to the universe as a dinosaur bone is to us. Voyager is not a message to the future. It is a tombstone for a species that wanted to be remembered. It is a scream into a canyon where the walls are too far away for an echo to ever return. This creates a state of scale disorientation. We look at the stars from Earth and they feel like decorations on a dome. We do not feel the depth. but the Voyager benchmark gives that depth a face. It shows us that space is not just big, it is a void so thorough that it challenges the very meaning of the word place. At the speed of light, you are crossing every single inch of that void, 1 second at a time. And as you leave the sun's influence and enter the true void between stars, the environment begins to change. The vacuum you once thought was empty is about to reveal its teeth. We have spent our history defining a vacuum as the absence of everything. We assume that if we can just reach light speed, we can slide through the void like a needle through silk. But as we leave the benchmark of Voyager behind and push toward our first destination, we have to face the most disturbing reality of all. The universe doesn't have a speedometer, it has an energy wall. And as we are about to discover, traveling at the speed of light doesn't just make you fast, it makes you a target. In the next section, we are going to look at the Proxima paradox. We will explore the reality of reaching the nearest star and discover why, even at light speed, the arrival is the most expensive anticlimax in human history. We will see why the closest star in the galaxy is still too far to ever call home, and why your first greeting to another world might be its death sentence. The arrival at another star is the most expensive anticlimax in human history. For 3 centuries, the human species has projected its highest hopes and its deepest longings onto a tiny, flickering red dot in the constellation of Centaurus. We call it the Golden Shore. In our mission brochures and our cinematic dreams, we imagine Proxima b as a second Earth, a lush, emerald sanctuary waiting for the touch of a pioneer's hand. We have spent trillions of calories of energy and decades of psychological endurance on the single assumption that the universe has prepared a seat for us at the table. But as you engage your ship's primary deceleration sequence, you begin to realize a truth that the telescopes never told you. The dream of the stars was a planetary hallucination. You have traveled 40 trillion kilometers to reach the future, only to find that the future is a graveyard. This is the 5th rung of the ladder, the Proxima paradox. We are going to explore why reaching the nearest star is a lesson in the absolute indifference of the cosmos, and why even at light speed, the arrival is just a faster way to realize how alone we truly are. To understand the weight of the arrival, you must first feel the physical violence of the stop. For 4.2 years of your life, you were a god of motion. You were a ripple in the fabric of space-time, screaming through the vacuum at the absolute maximum speed allowed by nature. But to see a star, you must dismantle the very velocity that brought you there. The deceleration phase is not a button press. It is a multi-month struggle against your own mass. As the engines roar back to life, pushing against the direction of travel, the weight returns, but it is a wrong weight. Your body, which has been living in the clinical stillness of the light speed bubble, finds the return of gravity to be a structural catastrophe. Your heart, now a thin muscle used to a world without resistance, struggles to pump blood through a frame that feels like lead. The machine is stopping, but the man inside is being crushed by the very physics that promised him a new beginning. As the ship finally settles into a high elliptical orbit around Proxima Centauri, the first high-resolution data begins to flood the bridge. You are the first human being to see another sun from a distance of just a few million miles, but you don't see the warm, golden glow of the sun you remember from your childhood. You see a dim, angry, and temperamental ember. Proxima Centauri is an M-type red dwarf, a star that is smaller and cooler than our own, but infinitely more volatile. Through the ship's filtered sensors, the star looks like a smoldering coal in a darkened room, casting a heavy, blood-red light across the scarred hull of your ship. There is no majesty here. there is only a sense of cosmic exhaustion. The golden shore is bathed in a light that feels like a permanent sunset over a world that never had a morning. Then you see the target, Proxima b. This is the world that justified the sacrifice of your identity. But as the image resolves on your monitors, the last remnants of 21st century optimism vanish. Proxima b is not the second Earth humanity imagined. It is a world that has survived for billions of years under the lash of a violent sun, and it bears the scars to prove it. It is an eyeball world, tightly locked to its star, forever showing one face to the fire and the other to the ice. On the day side, the red sun hangs motionless in a scorched, violet sky, baking the rocks until they glow with a dull, volcanic heat. On the night side, a frozen wasteland of nitrogen ice stretches into an eternal shadow where the temperature never rises above absolute zero. The only hope for life is the Terminator line, a narrow, razor-thin strip of permanent twilight between the furnace and the frost. You sit in the silence of the bridge, watching the data streams from the atmospheric probes. You are looking for the chemical fingerprints of home, oxygen, nitrogen, the signs of a breathing biosphere. But the sensors return a story of struggle. Proxima Centauri, in its billion-year tantrums, has processed its own children. Frequent stellar flares, hundreds of times more violent than anything produced by our sun, have sandblasted the planet's atmosphere into the void. Proxima b is not a sanctuary. It is a scorched, irradiated rock, as dead as the moon and as hostile as Venus. The habitable zone was a mathematical mirage that failed to account for the star's relentless personality. You have spent 4 years of your life in a metal tube to reach a destination that is no more welcoming than the vacuum you just crossed. This realization is the true breaking point for the light-speed traveler. On Earth, we are defined by our goals. We can endure almost any hardship if we believe there is a Y at the end of the road. But at Proxima Centauri, the Y is erased. You realize that you are the only living witness to truth humanity was never prepared to hear. The danger of leaving Earth was not only reaching another world. The danger was discovering that the universe may not contain another home waiting for us. You are standing at the pinnacle of human achievement, and you are seeing a mirror of your own loneliness. You aren't a pioneer. You are a castaway who has just realized that the island you reached is made of salt and ash. Think about the psychological toll of the 1,500-day silence. Even at light speed, the crossing took 4 years and 3 months. For 1,500 days, you had no one to talk to but the ship's AI. You had no horizon to look at but the digital maps. You believed that this isolation was a bridge, a temporary payment for a new world. But now that you have arrived, you realize that the bridge doesn't lead to a shore. It leads to a different kind of isolation. To land on Proxima b is to move from a metal cage to a rock cage. You would have to live the rest of your life in a pressurized bunker, huddling beneath meters of toxic dirt to hide from the star's flares. You would never breathe natural air again. You would never feel the warmth of a yellow sun. You have used the fastest speed in the universe to reach a place where you are more trapped than when you started. But the paradox has a final, much more unsettling layer, the weapon of arrival. As we explored in previous sections, a ship moving at light speed is not just a vehicle. It is a vacuum cleaner for the galaxy. Throughout your crossing, your ship's magnetic fields and gravitational wake have been sweeping up trillions of hydrogen atoms and microscopic grains of dust. This buildup is trapped at the leading edge of your ship, compressed into a layer of high-energy matter. And here is the wait. What moment that destroys the dream? The moment you decelerate, all of that trapped energy is released forward. Your arrival at Proxima Centauri is not a greeting. it is an astronomical execution. You arrive with a focused beam of radiation so intense it could incinerate the very world you were trying to settle. Your first step into a new solar system is the act that destroys it. This is the ultimate verdict of the Proxima paradox. The universe has set a safety lock on the stars. It tells us that if we try to cross the distance too quickly, we arrive as a catastrophe. We are forced into a choice between a slow journey that destroys the traveler or a fast journey that destroys the destination. We have spent centuries looking at the nearest star as a second chance for humanity, never realizing that the laws of physics have made that chance a contradiction in terms. The hero is home, but the home is dead. And the explorer is back, but the explorer is a stranger. As you sit in the blood-red light of Proxima, watching the radiation monitors spike and the sterile rocks glow, you realize that your journey was never an expansion. It was a retreat. You are fleeing an Earth that is already 4 years in your past, toward a world that has no future. And as you look further out into the galaxy, toward the bright lights of Sirius and Vega, you realize that the Proxima paradox is not an anomaly, it is the rule. In the next section, we are going to look at the galactic abyss. We will discover why crossing 1 light-year was the easy part, and why the scale of our own galaxy turns the speed of light into a meaningless crawl. We will see why the 100,000-year sentence is the ultimate prison for our species, and why the universe is a collection of isolated islands that were never meant to meet. Are you ready to see how big the dark really is? We have reached the limit of the human neighborhood. For nearly an hour, we have followed the arc of a journey that made the solar system feel like a small room, and the journey to our nearest star feel like a silent 4-year exile. We have used the fastest speed the universe permits, the absolute ceiling of reality, to tame the driveway of our own home. But as you look out from the blood-red light of Proxima Centauri and turn your gaze toward the wider horizon, you are about to hit a wall that no amount of momentum can overcome. This is the 6th rung of the ladder, the galactic abyss. In this section, we are going to explore why our own galaxy is not a neighborhood to be settled, but a gargantuan, rotating prison of time. We will discover why the speed of light, which felt like a godlike power in our own backyard, turns into a meaningless crawl when placed against the scale of the 100 billion stars that call this city home. To understand the scale of the abyss, you must first confront the 100,000-year sentence. Imagine that you don't just want to visit the nearest star, you want to see the other side of your own home. You point your ship toward the far edge of the Milky Way, lock the throttle at exactly 100% of the speed of light, and wait. On Earth, we measure our history in thousands of years, but the Milky Way is 100,000 light-years across. This means that at the maximum speed allowed by the laws of physics, crossing our own galaxy would take 100,000 years. Think about that span of time. 100,000 years ago, our species was a small, scattered population in Africa. We hadn't yet invented agriculture. We hadn't built a single city. We hadn't even begun the great migrations that would populate the continents. If an early human had boarded a light-speed ship at the moment of our species' birth and headed for the galactic rim, they still wouldn't have arrived. The entire history of humanity is not long enough to cross our own galaxy at the speed of light. This leads to the first what moment of the abyss, the realization that we don't live in a place, we live on a side street. Our sun sits about 26,000 light-years from the galactic center. We are tucked away in a modest spur of a spiral arm called Orion. We are in the cosmic suburbs. To reach the supermassive black hole at the heart of our galaxy, Sagittarius A*, you would have to travel at light speed for 25,000 years. Every message you sent home would take 25,000 years to arrive. You are launching a ship into a future where your own planet will have forgotten your name, your language, and the very reason you left, long before you even reach the halfway point. Light speed doesn't connect the galaxy. It only highlights how fragmented it truly is. We are like ants on a single leaf in a forest that spans 1,000 miles, unaware that the distance between leaves is greater than our entire existence. Think about the stellar crowd that hides the abyss. From Earth, we see a night sky filled with a few thousand stars. We assume that we are looking at the galaxy, but this is the ultimate deception of the human eye. Almost every single star you can see with your naked eye sits within a tiny local bubble that is less than 1% of the size of the Milky Way. You have never seen the other side of the galaxy. You have never even seen the stars in the next spiral arm. We are surrounded by an invisible majority, 400 billion suns that are so distant that their light merges into a single, ghostly wash of white. The abyss is not just empty space. It is an ocean of fire that is too large for our eyes to resolve. And your ship, moving at the absolute limit of physics, is trying to swim through this ocean one drop at a time. This leads us to the habitability mirage. We talk about the trillion planets that likely exist in the Milky Way. We imagine a future of interstellar trade and galactic commerce. But the galactic abyss reveals the energy and time debt that makes this dream an economic impossibility. Even if you have light-speed engines, you cannot have a civilization that spans 100,000 light years. A civilization requires a feedback loop, a shared conversation. But if the refresh rate of your empire is 1,000 years for a single question and answer, you don't have a society. You have a collection of ghosts who are perpetually out of sync. You arrive at a habitable world only to realize that it is a separate island of history, as disconnected from Earth as if it were in a different universe. The physical reality of the abyss also begins to manifest in the density trap of the galactic core. As you move toward the center of the Milky Way, the sky begins to change in a way that would shatter your terrestrial sanity. On Earth, our nearest neighbor is 4 light years away, but as you approach the core, the stars crowd together. In the central bulge, the average distance between suns drops to a fraction of a light year. You would be traveling through a region of space where the night sky is as bright as a summer afternoon. The radiation from 1,000 nearby suns would bathe your hull in a relentless, high-energy glow. You would be a god of speed, but you would be a god in a furnace. The very center of our world is a place where biology was never meant to go. And yet, at light speed, it still takes you 25 millennia just to reach the mouth of the monster. But the most humbling part of the abyss is the galactic rotation. Our entire solar system is currently racing around the center of the Milky Way at 500,000 miles per hour. We feel none of it, but it takes us 230 million years to complete a single lap. This is a galactic year. The last time the Earth was in its current position in the galaxy, the first dinosaurs were just beginning to appear. Since our sun was born, it has only made 20 trips around the core. We are living in a system of such immense scale and such ancient timing that our entire human story, from the first stone tool to the first warp drive equation, has happened in less than 0.1% of a single galactic day. We are mayflies trying to understand the geography of an empire that measures its life in eons. This creates a state of scalar vertigo. You realize that your ship, moving at the maximum speed allowed by nature, is essentially standing still. If you were to watch a time-lapse of the Milky Way over 1 billion years, your light-speed vessel would look like a microscopic parasite, crawling at an invisible pace across a giant, rotating wheel of fire. You have used the most powerful magic in physics just to realize that you are too small to ever matter to the galaxy. The speed mirage of Section 1 is now a total collapse. You see that the stars are not destinations. They are isolated cells in a structure that doesn't know you exist. And then there is the information decay of the stars. As you cross the abyss, you realize that the sky is lying to you more than ever. You see a brilliant supernova at the edge of your vision, but you realize that explosion happened 80,000 years ago. You see a cluster of stars that look stable, but you know that in there now, they have already drifted apart or died. You are navigating through a graveyard of light, trying to build a map of the present using the echoes of the deep past. The faster you go, the more you realize that now is a local luxury that the galaxy refuses to share. You are a citizen of no time and no place, lost in a between that spans 100,000 years. The galactic abyss has won, not by stopping your heart, but by making your timeline irrelevant. You have survived the Oort cloud wall and the Proxima paradox, but you're losing the battle for perspective. We are the first generation to realize that the most dangerous thing about the Milky Way is not its black holes or its flares. It is its sheer, unyielding volume. You have used the fastest speed in existence to cross your own city, only to find that you have spent your entire civilization's history just to reach the next block. But as the galaxy stretches away from you in every direction, as you realize that the 100 billion stars are just one island in a much larger ocean, a new and much more chilling question begins to form. If our own galaxy is this big, if light speed is this slow, then what happens when we look at the universe beyond our island? What happens when we realize that the space itself is growing faster than we can run? In the next section, we are going to look at the redshift prison. We will discover why the expansion of the universe is currently winning a race against the very light we are trying to use, and why the most distant galaxies we see tonight are already physically unreachable, even at light speed. We have tamed the galaxy, but we are about to meet the force that is dismantling the universe. Are you ready to see why the nothingness between galaxies is the ultimate weapon of our isolation? Imagine that you have finally left the City of Fire. Behind you, the Milky Way has shrunk from a sprawling empire of 400 billion stars into a single glowing spiral, hanging alone in a sea of absolute nothingness. You are standing on the deck of your impossible ship, moving at exactly the speed of light, and you are heading for the next island in the dark, Andromeda. This is the first time in human history that a biological mind has ever looked out across the intergalactic void. You expect to feel a sense of ultimate freedom. You expect the universe to open up like a vast, reachable frontier. But as you leave the gravitational shadow of your home, you are about to hit the most profound wall in the history of science. This is the redshift prison. We are about to discover why the expansion of space is the ultimate engine of our isolation, and why even at the maximum speed allowed by the laws of physics, we are living on a sinking island in an ever-widening ocean. To understand the horror of the expansion, you must first confront the law of the floor. For thousands of years, every explorer in human history followed a single intuitive rule. If you can see it and you move fast enough, you can eventually reach it. If you can see the mountain on the horizon, you can climb it. If you can see the far shore across the ocean, you can build a boat and sail to it. We have spent our history believing that sight is a promise of destination. But the universe breaks this ancient rule. In the 1920s, Edwin Hubble looked at the distant smudges of light we call galaxies and noticed something unsettling. Every single one of them, save for our immediate neighbors, was turning red. This was the first nishan of the redshift, the fingerprint of a universe that is being stretched like a piece of cosmic rubber. Most people believe that the galaxies are simply running away from us, like cars speeding down a highway, but the reality is much more malicious. The galaxies aren't moving through space, the space between them is growing. Imagine drawing two dots on a balloon. When you blow air into that balloon, the dots move apart. They aren't walking across the rubber itself is expanding. Now imagine you are a tiny ant on that balloon, trying to walk from one dot to the other at your top speed. This is your light speed ship. You are moving as fast as nature allows, but the floor beneath you is stretching. Every meter you cross is being replaced by 2 meters of new, empty space. This is the speed of nothing. The realization that while nothing with mass can travel faster than light, the empty space between galaxies has no such limit. It can stretch at any speed it wants. This leads to the first what moment of the redshift prison, the realization that the universe is winning the race. At the furthest edges of our vision, space is currently expanding faster than the speed of light. This creates a boundary that astronomers call the cosmic event horizon. It is a wall of logic that no amount of engineering can ever penetrate. Think about what this means for your light speed journey. You point your ship toward a galaxy 10 billion light years away. You are moving at the maximum speed possible, 100% of c, but as you travel, the space in front of you is stretching so fast that the distance to your destination is actually growing, not shrinking. You are like a man running up an escalator that is moving down faster than his legs can move. No matter how much energy you expend, and no matter how long you wait, you will never arrive. In fact, every second you travel, you are getting further away from the place you are trying to reach. The scale of this loss is staggering. If you look at the night sky through a powerful telescope, you can see 2 trillion galaxies. But because of the expansion of space, 97% of those galaxies are already causally severed from us. They have already crossed the cosmic event horizon. This is the information siphon of the void. The light they are emitting right now will never reach Earth. Even if we launched a beam of light today toward them, it would travel for 1 trillion years and never catch up. We are looking at a gallery of ghosts, images of worlds that have already vanished from our future. We are the survivors of a cosmic great reset, trapped in a tiny bubble of reachable space that is only about 18 billion light years wide. Beyond that line, the universe is effectively dead to us. Think about the psychological toll of the redshift drift. As a galaxy recedes from you, the light waves it sends are stretched out. Just as the sound of a siren drops in pitch as it speeds away, the light from these stars drops in frequency. Blue light turns yellow, yellow light turns red, and eventually red light turns into infrared. It moves out of the visible spectrum and into the darkness. Your cockpit window, which once showed a universe full of color, slowly begins to bleach. One by one, the distant superclusters fade into dim red embers and then vanish into the heat signature of the vacuum. You aren't just losing your destinations, you are losing your vision. You are witnessing the permanent sunset of the cosmos. The universe is methodically painting its windows black, hiding its majesty from you until only your own home is left in the light. This creates the peak of existential loneliness. We talk about an interstellar civilization, but the redshift prison proves that even a local group civilization is a fragile dream. In Section 5, we saw how it takes 4 years to hear a hello from Proxima Centauri, but in the intergalactic abyss, the delay is measured in millions of years. If you send a message to the Andromeda galaxy at the speed of light, and they answer immediately, your children's children, 10,000 generations later, will still be waiting for the response. There is no conversation here, there is no shared history. We are each marooned on our own island of stars, able to shout across the void, but never to hear an answer come back in time to matter. The speed of light, which felt like a miracle in the solar system, has turned into a crawl that ensures every civilization stays in solitary confinement. But why is this happening? Why is the universe in such a hurry to tear itself apart? The answer is the most mysterious force in science, dark energy. It makes up 68% of everything that exists, yet we cannot see it, touch it, or measure it directly. We only know it by what it does. It acts as a cosmic anti-gravity, pushing the galaxies away from each other at an ever-increasing rate. Dark energy is the antagonist of our story. It is the force that is currently winning the war against gravity. It is dismantling the cosmic web, tearing the filaments of Laniakea apart, and ensures that as time goes on, the universe becomes emptier, colder, and darker. We are living in a brief golden hour of visibility, a window of time when the universe is still close enough for us to see, but the window is closing. The final irony of the redshift prison is the archaeology of the night. If you were born in the Milky Way 100 billion years from now, you would look at the sky and see only the stars of our own merged galaxy. The expansion of space would have carried every other galaxy beyond your horizon. The evidence for a Big Bang would be gone. The evidence for an expanding universe would be invisible. You would believe your galaxy was the entirety of existence, alone in an infinite, empty dark. You would be wrong, but through no fault of your own. You would simply be a victim of the timing. You would be born too late to see the truth. We are the lucky generation that still has the clues on the wall, but we are also the generation that has to live with the realization that the wall is moving away. The redshift prison has won, not by stopping your engines, but by making your speed irrelevant. You have built a ship that can move at the speed of light, but you have found that the space itself is faster. You have survived the galactic abyss, but you are losing the race against the nothingness. We are the first generation to realize that the most dangerous thing about the universe is not its black holes or its flares. It is the fact that it is slipping away. You have used the maximum speed of nature to realize that you are still a prisoner of your own coordinates. But as the galaxies fade into the infrared dark, as you realize that the trillions of suns are fleeing from you, a new and much more intimate nightmare is waiting for you back on the ship. We think that if we can just accept the isolation, if we can just endure the lag of reality, we will find meaning in the journey. But light speed has one final, much more personal tax for those who dare to use it. It doesn't just isolate you in space, it isolates you in time. In the next section, we are going to look at the information decay. We will explore why real time is a local glitch that the universe refuses to share, and why even at light speed, your own memory becomes a foreign language. Are you ready to see why the speed of light is not just a speed limit? It is a psychological cage. We are a species built on the rhythm of the shared now. In our everyday lives, we live with the unwavering assumption that the present moment is a universal truth, a single, synchronized heartbeat that pulses across the entire world at once. When you look at your watch and see that it is noon, you assume it is noon for everyone on the planet at exactly the same instant. We have built our history, our laws, and our relationships on this foundation of simultaneity. It is the safety net of our sanity, the invisible thread that allows us to believe that no matter where we are still part of the same story. But as you push your starship deeper into the intergalactic void at the speed of light, this foundation doesn't just crack, it vanishes. You are about to discover that in the true scale of the universe, now is a local glitch, a fragile temporary illusion that the cosmos refuses to share. This is the information decay. In this section, we are going to explore why communication across light years is not a conversation, but a form of archaeology, and why the faster you travel to find your way, the more the universe turns the people you love into ghosts of a distant past. To understand the horror of information decay, we must first confront the lag of reality. We have spent our history defining speed as a way to get closer to things. We think that if we move faster, we become more current. But in a universe where the speed of light is the absolute ceiling, speed is actually an engine of isolation. We saw in our earlier sections that light takes time to travel. This means that information has a shelf life. It has a refresh rate. On Earth, this rate is so high that it feels instantaneous. When you speak to someone across the room, the information reaches them in a fraction of a millisecond. But as you move into the interstellar dark, the refresh rate of your reality begins to collapse. You are no longer living in the present. You are living in a delayed time snapshot of a universe that has already moved on without you. Think about the causal divorce of a simple greeting. Imagine you have reached the orbit of Proxima Centauri, 4.2 light-years from home. You are moving at the speed of light, yet you are still separated from Earth by a gap of 1,500 days. You decide to send a message home, a simple "I have arrived." On Earth, your family receives that message 4 years and 3 months after you sent it. They celebrate, they weep with relief, and they send a reply immediately. That reply takes another 4 years and 3 months to reach you. This is the first wait. What? Moment of information decay. A single hello and hello back has consumed nearly 9 years of human history. In that time, the world you described in your first message has already been rewritten. The child you mentioned is now in school. The political crisis you worried about is forgotten. You aren't communicating with a living world. You are corresponding with a graveyard of memories. This leads us to the information siphon of distance. On Earth, we are used to the idea that information is preserved. We record our history, and we expect it to stay relevant. But in the deep dark, information decays just like a radioactive isotope. The further it travels, the less useful it becomes. By the time the news of a technological breakthrough on Earth reaches your ship at 90% of light speed, that technology is already 10 years old. By the time you receive the update, the engineers who designed it have already moved on to the next version. You are perpetually trying to inhabit a future that has already become the past. You are a biological relic, running on outdated software, trying to find your place in a species that is evolving faster than your radio can track. You aren't a pioneer expanding the reach of humanity. You are a piece of data that was never meant to be read twice. The psychological toll of this temporal vertigo is a slow-motion dismantling of the self. Human identity is maintained through interaction. We see ourselves reflected in the eyes of our peers and the current events of our society. But for the light-speed traveler, the mirror is broken. You are a mind that has been surgically removed from the collective timeline. You might receive a video of a summer rainstorm in your hometown, but as you watch the waterfall, you realize that the rain ended years ago. You are mourning people who haven't even died yet in your now, but who have been dust for years in their own. You start to lose the language of the moment. Why care about the politics of a planet that won't hear your opinion for a decade? Why invest in the emotions of a family that is aging while you are frozen in the stillness of sea? You begin to retreat into the only reality that is left, the ship. The metal walls become more real than the earth. The hum of the fans becomes more important than the voices of the past. But the decay is not just about time. It is about intensity. This is the inverse square law of the soul. As a radio signal travels away from its source, it spreads out in every direction, its energy thinning as it covers an ever-widening sphere of space. To Earth, your ship's signal is a candle flame in a hurricane of galactic noise. To catch your voice, humanity must build massive radio dishes the size of cities, filtering through the screaming of pulsars and the background hiss of the Big Bang. As you move further away, the signal-to-noise ratio of your existence drops. You reach a point where your hello is no longer a sound, it is a statistical probability. Eventually, the distance becomes so great that the universe simply swallows your information. The umbilical cord doesn't just stretch, it evaporates. You reach the final silence, not because your radio broke, but because the universe decided that your story was too faint to be heard anymore. This brings us to Einstein's most unsettling revelation, the death of absolute simultaneity. He proved that there is no universal right now that connects the galaxies. If two observers are moving at different speeds, they will not agree on the order of events in the universe. This is the relativity of information. From your perspective on the ship, you might see a star explode at the same moment you receive a message from Earth. But to the person on Earth, those two events happen centuries apart. There is no master clock in the cosmos. The universe is not a single, synchronized stage. It is a collection of causal islands, each one living in its own private version of time. You are trying to find your way home in a world where the landmarks are not only moving, but are existing in different histories. You are navigating a house where every room is in a different century, and the hallways are made of nothingness. Think about the legacy of the echo. If humanity were to send a fleet of light-speed ships to colonize the nearest 100 stars, we would not be building an interstellar empire. We would be initiating a civilizational divorce. Within a few centuries, the colonies would drift apart, not just in distance, but in language, culture, and biology. Each system would become its own now, its own history, and eventually its own species. The speed of light ensures that no two star systems can ever truly share a single destiny. We are a planetary species, designed for the instant and the local. The moment we reach for the light, we are signing a warrant for our own fragmentation. We are choosing to become a collection of isolated whispers in a room that is too large for any shout to reach across. This realization leads to the ultimate Fermi connection. Why is the sky so quiet? Perhaps it isn't because the aliens are dead. Perhaps it is because they have all reached the same conclusion, that communication is futile. They have done the math on information decay and realized that an interstellar conversation is a game of talking to ghosts. They have accepted their isolation, choosing to perfect their own local group, rather than wasting their energy shouting into an abyss that only returns an echo 1,000 years later. The silence of the stars is the sound of 1 billion civilizations deciding that home is the only thing that actually exists. We are the infants who haven't yet realized that the telephone is broken, and we are still waiting for a call from a world that has already moved on. The information decay has won, not by stopping your heart, but by making your voice irrelevant. You have built a ship that can move at the speed of light, but you have found that the universe is a series of closed rooms. You have survived the redshift prison, but you are losing the battle for connection. We are the first generation to realize that the most dangerous thing about the universe is not its radiation or its black holes. It is its unsinkability. You have used the maximum speed of nature to realize that you are still a prisoner of your own timeline. But as the signals fade into the static and the voices of Earth become historical recordings, a new and much more physical trap is forming at the edge of your ship. We think that if we can just accept the loneliness, if we can just endure the silence, we will reach the stars. But the physics of C has one final, crushing tax for those who dare to move at the absolute limit. It doesn't just isolate you in time, it threatens to dismantle your very mass. In the next section, we are going to look at the time dilation trap. We will explore why reaching the speed of light without losing your body is a mathematical impossibility, and why the universe protects its refresh rate with a violence that defies every law of engineering. Are you ready to see why the speed of light is not just a limit? It is a death sentence for matter. We have spent this journey imagining a vessel that has broken the ultimate seal of the universe. We have granted ourselves the speed of light as if it were a simple mechanical achievement, a faster engine, a better fuel, a more efficient hull. But as we transition from the information decay of Section 8 to the raw mechanics of the clock, we must confront a realization that turns our fastest dream into a psychological cage. You are about to discover that speed is not just a measurement of how fast you move through space, it is a trade you make with existence. You do not conquer the light, you buy it, and the currency you use is time. This is the time dilation trap. We are about to see why the speed of light is not a bridge to the stars, but a physical blade that methodically severs the traveler from the human timeline. We are going to explore why, at the absolute limit of physics, your own heartbeat becomes a weapon that erases the world you left behind. To understand the horror of the trap, we must first look at the energy penalty of reaching for the light. Einstein's theory of special relativity, confirmed by every particle accelerator and atomic clock experiment in history, reveals that the universe has a built-in resistance to motion. As an object with mass, whether it is a single proton or a 300-meter starship, approaches the speed of light, the energy required to push it even a fraction faster does not grow in a straight line. It curves upward toward infinity. This is the relativistic tax. To take our hypothetical ship from 0 to 99% of light speed requires a staggering amount of energy, but to push it that final 1% to reach the absolute ceiling of C would require more energy than exists in every star and every black hole in the observable universe combined. The universe protects its speed limit with a ferocity that defies our imagination. It ensures that anything made of atoms is forever locked in a state of slower than now. But let's assume we paid the debt. Let's assume we cheated the energy equations and reached the full speed of light. Here is the first wait. What? Moment of the trap. For a beam of light, time does not exist. If you could somehow hitch a ride on a photon leaving the sun, your subjective experience of the journey to Earth would be instantaneous. You would not feel the 8-minute delay. You would not see the planets flicker by. You would leave the surface of the sun and arrive in the upper atmosphere of Earth in the exact same heartbeat. At the speed of light, the universe has no depth. It is a flat, two-dimensional sheet where departure and arrival are the same event. This is the God mode of physics, a state of absolute, eternal presence where the traveler is everywhere and nowhere at once. But for you, the biological traveler, this is where the temporal execution begins. While your subjective clock has stopped, the rest of the universe is still ticking. If you were to travel across the Milky Way at the speed of light, your journey would feel like 0 seconds. You would step onto your ship in New York and you would step off at the galactic rim a second later. But while you experienced nothing, 100,000 years would have screamed past on Earth. Every mountain you knew has eroded. Every ocean has shifted its shores. The human species, if it still exists at all, would be as alien to you as you are to a Neanderthal. You have used the maximum speed of nature to skip ahead into a future that has no memory of your name. You arrive young at your destination, only to realize that you are an archaeological specimen, a biological ghost from a civilization that died while you weren't even looking. Think about the psychological vertigo of this mismatch now. Human identity is built on the continuity of our relationships. We are defined by the people who remember us and the events we participate in. But the time dilation trap severs this continuity with a clinical, mathematical precision. Imagine you are the pilot of a light-speed ship on a mission to a star system 40 light-years away. You have a wife and a 5-year-old son. You launch, you experience a moment of flight, and you arrive. But when you point your sensors back toward home, you aren't looking at your family. You are looking at a world where your son is now 45 years old. He has lived an entire life. He has loved, he has suffered, he has succeeded, and you weren't there for a single second of it. To him, you are a photograph in a history book. To you, he was a child only a heartbeat ago. You are truly, profoundly later than the human race. This leads us to the grave of the shared story. Most people believe that interstellar travel is about expansion, spreading our culture to the stars. But the time dilation trap ensures that any civilization that travels at relativistic speeds will inevitably fragment. If it takes you 4 years to reach Proxima Centauri, and 4 years to return, you have lost nearly a decade of Earth's time. If you travel to a star 100 light-years away, you have lost 2 centuries. You cannot have a unified government, a shared economy, or even a common language when the refresh rate of your society is measured in generations. The speed of light acts as a causal lockdown, ensuring that every solar system remains a sovereign island of time. We are choosing to become a collection of isolated whispers in a room that is too large for any shout to reach across. We are trading the unity of our species for a view of a foreign sun. The physical reality of the trap also begins to manifest in the biological reset of the traveler. We imagine ourselves as conquerors of the stars, but we are actually planetary accidents, fine-tuned to Earth's specific rhythm. Move a human to a light-speed ship, and you are initiating a metabolic divorce. While your clock is running slow, your body is still subject to the entropy of the small. The cosmic rays we discussed in Section 1 don't care about your time dilation. Even if you only experience a few months of travel, the dosage of radiation you receive is based on the distance you cross. You arrive at the nearest star having aged only weeks, yet your DNA carries the scars of 4 light-years of bombardment. You are a young man with the genetic age of a century. The universe has found a way to tax your biology even when it cannot tax your time. Think about the final, most unsettling irony of the trap, the obsolescence loop. Think about the speed of human progress. If you launch a ship today that takes a century of Earth time to reach its goal, it is statistically certain that halfway through your journey, humanity will develop a better engine. Because you are trapped in the slow time of your ship, you cannot receive the upgrades. You are running on the software of a previous era. A ship launched 50 years after yours could be twice as fast, overtaking you in the dark and arriving at the destination decades before you. You arrive at your new world, only to find a welcoming committee that has been there for 50 years. They look at your ship as a primitive curiosity, a high-tech wooden canoe in a world of supersonic jets. Your entire life of sacrifice was made redundant by the very progress you were trying to advance. The time dilation trap has won, not by stopping your engines, but by making your presence irrelevant. You have built a ship that can move at the speed of light, but you have found that you cannot bend the clock. You have survived the redshift prison and the information decay, but you are losing the battle for belonging. We are the first generation to realize that the most dangerous thing about the universe is not that it is far, it is that it is future. We have used the maximum speed of nature to realize that we are still prisoners of our own coordinates. You look out the viewport at the stars, and you realize that they are not destinations. They are the boundaries of your social extinction. But as the realization of your isolation sets in, as you realize that the trillions of suns are fleeing from you into a future you can never touch, a new and much more chilling question begins to form. If the math of the time dilation trap is so absolute, if navigating the light years is so lethal and so lonely, then why haven't we seen anyone else doing it? If light speed is a mathematical ceiling and we are all trapped under it, then where are the other prisoners? Why is the sky so quiet? In the next section, we are going to look at the Fermi connection. We will explore the possibility that the slowness of light is the very reason we have never heard from another world. We are going to ask if the time dilation trap is the ultimate great filter of the universe. Are you ready to see why the silence of the stars might be the most terrifying data we have ever collected? If the door to the stars is open, then why is the hallway so quiet? For nearly a century, humanity has lived with a nagging existential question that haunts every telescope and every radio dish we point at the sky. Enrico Fermi, the legendary physicist, famously summarized the problem during a casual lunch in 1950. Where is everybody? The Milky Way is 13 billion years old. It contains 400 billion stars and trillions of planets. Even without the impossible ship we've been using tonight, a civilization moving at just 1% of the speed of light could colonize the entire galaxy in a mere 50 million years, a blink of an eye in cosmic time. But tonight we must confront the most disturbing version of this paradox. If light speed is a mathematical reality, if the universe genuinely provides a maximum limit of 300,000 kilometers per second, then the silence of the stars is no longer just a mystery. It is a verdict. This is the Fermi connection. In this section, we are going to explore the possibility that the speed of light is not the bridge that connects civilizations, but the very filter that ensures they never meet. We are going to discover why the absolute limit of physics is the reason the galaxy remains a graveyard of isolated minds. To understand the weight of the silence, we must first look at the footprints of the gods. On Earth, we assume that a technologically advanced civilization would be loud. We look for radio signals, laser pings, and the heat signatures of Dyson spheres, massive structures built to harvest the entire energy of a star. But if a civilization had mastered travel at the speed of light, they wouldn't just be loud, they would be visible across the spectrum of reality. A light-speed ship is not a stealthy vehicle. It is a high-energy intervention in space-time. As we explored in previous sections, a vessel moving at sea would produce a distinctive high-energy signature, a blue-shifted flare of radiation and gravitational ripples that should be detectable from thousands of light years away. If thousands of civilizations were regularly racing across the galaxy at the speed of light, the sky should be flickering with the lights of their arrivals and departures. This leads to the first what moment of the Fermi connection, the signature gap. Despite our increasingly sensitive gravitational wave detectors and gamma-ray telescopes, we have seen zero evidence of relativistic travel. We haven't detected the Cherenkov-like glow that a ship should shed as it interacts with the quantum vacuum. We haven't seen the information trails of a connected galaxy. The sky is not a busy harbor filled with the wakes of starships. It is a stagnant, unmoving pond. This realization suggests one of two terrifying possibilities. Either we are the first species in 13 billion years to ever reach for the light, or the speed of light itself is so agonizingly slow that no civilization ever survives long enough to make the connection meaningful. This brings us to the concept of the Great Filter, the idea that there is a wall in the development of life that almost no one crosses. Most discussions about the filter focus on nuclear war or biological collapse. but the Fermi connection suggests a physical filter. Perhaps the filter is the speed of light itself. If light speed is the maximum rate of information, then the causal radius of a civilization is permanently limited. We imagine a galactic community, but the physics of light ensures that we are living in causal silos. A civilization can only influence a tiny bubble of space around its own star before the lag of reality we explored in Section 8 makes expansion irrelevant. The silence of the stars might not be a lack of life. It might be the sound of a billion civilizations realizing that they are too far away to ever matter to anyone else. Think about the synchronicity trap. The universe has been around for 13.8 billion years. Human civilization has existed for 10,000. If another civilization rose and fell 1,000,000 years ago, their light has already passed us by. If another rises 1,000,000 years from now, we will be long gone before their first signal arrives. To find each other, two civilizations must not only exist in the same galaxy, they must exist in the same temporal window, and that window must be wide enough for light to bridge the gap. If the average lifespan of a technological species is 10,000 years, but the average distance between them is 50,000 light years, they will never hear each other. They are like fireflies flickering in a dark forest, each one blinking in the silence, never realizing that another light existed just a few miles away, but at a different hour of the night. The psychological toll of the Fermi connection is a state of social erasure. Elias Thorne, during his subjective years in the void, became obsessed with this silence. He had been sent to find a neighbor, but he found only the red indifference of Proxima. Through his sensors, he had listened to the background radiation of the galaxy for 80 years, searching for a single artificial tremor. He found nothing. And in that silence, he realized the most unsettling truth of all. The universe is not a shared space. It is a collection of sovereign prisons. Each star is a cell, and the light years are the walls. Light, which we thought was a messenger, is actually the sensor of the cosmos. It ensures that every species develops, dreams, and dies in absolute clinical isolation. This leads to the rational retreat of the advanced mind. If a civilization reaches the point where they can do the math on the galactic abyss, they also reach the point where they realize that out is a losing game. As we saw in Section 9, interstellar travel is a negative-sum game. You must expend more energy than you could ever hope to harvest. You must sacrifice your timeline and your identity for a view of a dead rock. A civilization that survives long enough to understand this would realize that there is no galactic empire. There is only home. The Fermi silence is the sound of a billion civilizations deciding that the most efficient way to exist is to turn their gaze inward, living in perfect, managed stability around their own sun, while the stars burn out in the distance. We are looking for explorers, but we are looking in a universe of homebodies. Think about the archaeology of the signal. We have been broadcasting for a century. Our radio bubble is 100 light years wide. On the scale of the Milky Way, that bubble is a microscopic dot, invisible to 99% of the galaxy. If an alien astronomer is looking at the Earth tonight from the other side of the galaxy, they aren't seeing our cities or our satellites. They are seeing the Earth as it was 26,000 years ago, a world of ice and mammoth hunters. To them, we aren't technological, we are prehistoric. And by the time our radio signals reach them, their own civilization might be a memory. We are shouting into a room where the laws of physics ensure that every listener is already dead by the time they hear the shout. This creates the peak of existential humility. We are the infants who haven't yet realized that the telephone is broken. We are still waiting for a call from a world that has already moved on. The speed of light has won, not by hiding the aliens, but by making them irrelevant to our story. We have used the maximum speed of nature to realize that we are still alone in the dark. You look out the viewport at the billions of suns, and you realize that they are not invitations to meet. They are monuments to the fact that you never will. The speed mirage of Section 1 is now a permanent lockdown. But as the silence of the galaxy sinks in, as you realize that the trillions of suns are fleeing from you into a future you can never touch, a new and even more staggering scale is waiting for you. We have tamed the galaxy in our minds, but we are still ignoring the abyss between the galaxies. We think that the Milky Way is the limit of our isolation. But beyond our island of stars lies a void so vast that it makes the light years look like millimeters. In the next section, we are going to look at the void between superclusters. We will explore the discovery of the great voids and why even at light speed, leaving our galaxy is an act of permanent disappearance. We will see why the most terrifying thing in the universe isn't the stars we can see. It's the millions of light years of nothingness we can't. Are you ready to see the true edge of the cage? Every map we have ever made of the universe is a map of connections. We look at the filaments of the cosmic web, gargantuan threads of galaxies stretching for billions of light years, and we assume that these structures are bridges. In our imagination, we see these cosmic veins as the highways of our future, believing that if we can only move at the speed of light, we can weave our way through the grand architecture of the cosmos, hopping from one supercluster to another. But as we step off the edge of our home supercluster, Laniakea, we discover a truth that no telescope can soften. The universe is not a web of connections, it is a system of uncrossable borders. We are about to enter the great voids, the emptiest places in existence, where the speed of light is no longer a tool for travel, but a sentence of permanent isolation. In this section, we are going to explore the 11th rung of our ladder and discover why the nothing between galaxies is the ultimate engine of our loneliness. To understand the scale of this isolation, you have to look at our home, Laniakea. It is a Hawaiian word meaning immeasurable heaven. It is a structure that spans 500 million light years and contains over 100,000 galaxies, including our own. Laniakea is a cosmic watershed, a region where every galaxy is flowing toward a single gravitational heart called the Great Attractor. For millions of years, we have been part of this massive intergalactic river, moving toward a destination hidden behind the dust of our own galaxy. But here is the first wait. What moment of the deep abyss we will never arrive? Even though we are moving toward the Great Attractor at hundreds of miles per second, the space between us is expanding faster than we are falling. We are like a leaf in a river, being pulled toward a waterfall, while the river itself is growing longer every second. We are destined to drift in a state of eternal transit, moving toward a heart we can never touch. This leads us to the law of the floor. For thousands of years, every explorer in human history followed a single intuitive rule. If you can see it on the horizon and you move fast enough, you can eventually reach it. But as we look out from the edge of Laniakea, the universe breaks this ancient rule. We see other superclusters, Shapley, Perseus Pisces, Coma, glittering in the distance. But we aren't just far away from them, we are expanding away from them. This is the realization of the speed of nothing. While the speed of light is the absolute limit for anything moving through space, the empty space between superclusters has no such limit. It can stretch at any speed it wants. At the scales we are now discussing, the nothingness between our home and our neighbors is stretching faster than the speed of light. Think about what this means for your light-speed ship. You point your bow toward a distant cluster 10 billion light years away. You are moving at the maximum speed possible, 100% of sea, but as you travel, the floor beneath you is stretching so violently that for every meter you cross, 2 meters of new, empty space are created in front of you. You are like a man trying to cross an ocean that is getting wider with every stroke of his arms. No matter how much energy you expend, and no matter how long you wait, you will never arrive. In fact, every second you travel, the destination you are aiming for is getting further away. You have reached the cosmic event horizon, the boundary where light itself loses the race against the void. The scale of this loss is staggering. There are 2 trillion galaxies in the observable universe, but because of this stretching, 97% of them are already causally severed from us. They have already slipped over the horizon of our possible reality. This is the information siphon of the void. The light those galaxies are emitting right now will never reach Earth, not in a billion years, not in a trillion. We are looking at a gallery of ghosts, images of worlds that have already vanished from our future. We are the survivors of a cosmic great reset, trapped in a tiny bubble of reachable space while the rest of infinity flees from us into the dark. But the nothing has another weapon, the great voids. To feel the true weight of our confinement, imagine steering your ship into the Boötes void. This is a region of space 330 million light-years in diameter that contains almost no galaxies at all. It is a dead zone in the fabric of the cosmic web. If you were to cross this void at the speed of light, you would spend 330 million years in absolute, total darkness. There would be no stars in your window, no planets to see, no radio signals to catch. You would launch as a member of the human species and arrive on the other side long after your species, your planet, and even your sun had ceased to exist. In the intergalactic abyss, light speed is not a velocity, it is a chronological sentence. It turns every journey into a one-way trip into the end of time. This creates the peak of existential humility. We talk about the bigness of the universe, but we don't feel its depth. The void between superclusters gives that depth a face. It shows us that the universe is not a shared home. It is a system of sovereign cells. Each supercluster is a cell, and each galaxy is a grain of dust inside that cell. The expansion of space acts as the ultimate security protocol, ensuring that no 2 cells ever truly merge. We are looking for a galactic community, but the physics of expansion ensures that the only thing we will ever have is our own small group. We are cosmic orphans, huddling together for warmth around a dying sun, while the rest of existence is methodically being erased from our future. The intergalactic void has won, not by stopping your engines, but by making your speed irrelevant. You have built a ship that can move at the speed of light, but you have found that the universe is a series of islands that are getting further apart every second. You have survived the galactic abyss, but you are losing the race against the expansion. You have used the maximum speed of nature to realize that you are still a prisoner of your own coordinates. You look out the viewport at the fading galaxies, and you realize that the most dangerous thing about the universe is not its radiation or its black holes. It is the nothing in between. But as the galaxies fade into the infrared dark, as you realize that the trillions of suns are fleeing from you into a future you can never touch, one final realization remains. We have looked at the numbers, the math, and the barriers. We have seen why light is too slow for the scale of the cosmos, but we haven't yet asked why it was built this way. Why give us the intelligence to see the light if we are never meant to catch it? In our final section, we are going to look at the final verdict. We will explore the philosophy of the speck and the true reason why the universe is a collection of isolated islands. We will discover that the greatest victory of our species was not reaching for the light, but understanding why the backyard was enough. Are you ready for the final, heartbreaking realization of the human odyssey? The ladder is finished. Now we must look down. We have reached the end of the ladder. We have traced the arc of a journey that began with a miracle and ended with a realization. We have used the fastest speed the laws of nature permit, the absolute ceiling of 300,000 kilometers per second, and we have used it to climb through the layers of our own cosmic insignificance. We watched as light speed tamed the solar system in a single afternoon, making the gas giants feel like rare islands in a small room. But we also watched as that same speed faltered at the driveway of our own home, needing more than a year just to cross the property line of our sun's empire. We saw the Proxima paradox, where our nearest neighbor remained a 4-year silent exile, and we witnessed the galactic abyss, where the history of our entire species was not long enough to cross a single city of stars. And finally, we stood at the edge of the intergalactic void, watching as the expansion of the universe outran even our fastest light, leaving us in a shrinking bubble of fading history. And now, as we look down from the summit of this exploration, we are faced with the final, most humbling verdict of the human odyssey. It is not a verdict of technical failure or biological weakness. It is a verdict of perspective. We have spent this journey asking if light speed is too slow. The honest answer is that light is unimaginably fast, but the universe is simply too deep. To understand the meaning of this depth, we have to look back at the grain of sand. Throughout this journey, we have treated the distance between stars as an obstacle, a mistake of the cosmos that keeps us from our destiny. We imagine that if the stars were closer, or if light were faster, our lives would be richer. But as we reach the end of the map, we have to confront a much more profound possibility, that the distance is not an obstacle, it is a gift. The trillions of miles of absolute nothingness that separate us from our neighbors are the only reason we were ever allowed to exist in the first place. Stars need vast volumes of space to collapse from cold clouds of gas. Planets need billions of years of stable, unmanaged peace to develop the chemistry of life. If the universe were small, if the stars were crowded together like the lights of a city, the radiation of 100 suns would have sterilized our world before we ever learned to speak. Our isolation is our sanctuary. The very distances that make the universe hard to cross are the same distances that make the universe a home for complexity. This leads us to the philosophy of the speck. We often feel a sense of despair when we look at the scale of the cosmos. We see the 93 billion light-year bubble and we feel microscopic. We see the 2 trillion galaxies and we feel redundant. We look at the speed mirage and we feel slow. But this is the ultimate deception of scale. Rarity is the only true currency of the universe, and we are the rarest event we have ever found. The bigness of the universe is the context that defines our value. If the stars were easy to reach, they would be trivial. Their distance is what makes them sacred. By making the crossing impossible for our bodies, the universe has forced us to use something much more powerful, our minds. The fact that we even know how far it is to Proxima Centauri, that we can calculate the redshift of a galaxy 10 billion light-years away, is a greater achievement than any ship we will ever build. We are the dust that woke up and decided to measure the storm. Think about the legacy of the effort. Why did we build Voyager 1? Why did we spend half a century tracking a car-sized probe into the dark? Voyager is currently about 22 light-hours away, and as we discussed, its plutonium heart is dying. Within the next few years, the signal will vanish entirely. The umbilical cord of radio contact, which we have held onto like a religious lifeline, will finally snap. Voyager will become what it was always destined to be, a message in a bottle thrown into an ocean by a civilization that knew its own island was eventually going to sink. On the side of that probe sits the golden record, carrying the music of Bach, the sound of rain, and the laughter of human children. It is an invitation to a neighborhood that physics ensures will never be visited. But the record is not a failure. It is a defiance. It is a signal to the void that for one brief, flickering moment in the history of time, there was a species that refused to stay in its backyard. The psychological toll of our journey is a slow-motion homecoming. We imagine the pioneers of the future as people who leave the Earth to find a new world. But as we have seen, to leave the Earth is to lose the Earth. To visit the stars is to say goodbye to the human timeline forever. You return from your 4-year journey at light speed, only to find a world that has aged, changed, and forgotten your name. You realize that home is not a coordinate in space. It is a biological and social equilibrium that exists only in this specific moment of history. The lesson of light speed is that you cannot outrun time without erasing your own context. It tells us that we are a planetary species, and that our future is not on another world, but with the one we were built for. This provides the final answer to the Fermi paradox. We look at the silence of the galaxy and wonder why no one has called us. Perhaps it isn't because they are dead. Perhaps it is because every advanced intelligence eventually reaches the same mathematical realization that we are reaching today, that the universe is intentionally partitioned. The laws of nature act as a cosmic quarantine, ensuring that life remains a local, precious event. The silence of the stars is not a mystery to be solved. It is a law to be obeyed. Other civilizations may have already accepted their isolation, choosing to perfect their own local cradle rather than wasting their potential on a race they can never win. The speed of nothing has ensured that the galaxy remains a graveyard of isolated minds, each one a unique experiment in a different causal silo. As the sun sets on this exploration, I want you to look at the night sky one last time. But this time, don't look at it as a map of distance. Look at it as a gallery of ghosts. Every point of light you see is a sun that follows the same laws as yours. Every smudge of dust is a galaxy that grew from the same ripples in the fabric of reality. We have spent this time proving that these places are unreachable, but we have also proven that they are comprehensible. We sit on a small planet, orbiting an ordinary star, in an unremarkable arm of a typical galaxy. We have never sent a living person beyond our own moon. We are, by every honest measure, hopelessly local and agonizingly slow. And yet, from this tiny vantage point, we have mapped the entire history of a universe that is 93 billion light-years wide. We have decoded the light of suns that died before our planet was a spark. We have stood at the edge of the abyss and grasped its proportions. The final verdict of our impossible journey is this: comprehension is the only true way to travel. You cannot cross the void with a ship, but you have crossed it today with your mind. When you truly understand what a galaxy 2.5 million light-years away is, when you grasp that its light has traveled through an infinite silence just to touch your eye, you have, in a sense, already arrived. No expansion of space and no limit of physics can ever take that away from you. We are the witnesses of the cosmos. We are the way the universe looks back at its own majesty. And in a universe of infinite scale and absolute isolation, being the only ones who can see the light is the greatest triumph of all. The airlock is closed, the engines are silent, the pioneer is at rest. The ladder of scale has reached its peak, and as we look down from the height of our ambition, we see the Earth for what it really is. A tiny, fragile spark in a black ocean, a noisy room in a silent house, and the only place in the entire universe where you can ever truly be found. The stars are far, but the grass is near. The distance is the barrier, but the understanding is the key. Keep looking up, but never forget to look back. For as long as we can see the light, the universe belongs to us. Thank you for joining me on this odyssey into the deepest mysteries of the void. If this exploration of the limits of our speed has changed the way you look at the stars and the world beneath your feet, please take a moment to like the video and subscribe to the channel. Your support allows us to continue building these cinematic bridges into the unknown. And the next time you feel the pull of the night sky, just remember, light is fast, but wonder is faster. Good night, and may your path always lead you home, even when the stars say there is no road back.